Quotients are fractions. Okay, so we're going to use this when you have a situation that looks like this. So you've got one expression on top of the other. Okay. Now, whilst before it didn't matter which one was u and which one was v, because they were being multiplied together for a start, and then our rule had an addition sign in, you can see that this rule here is way more complicated. Okay, it's for a start, it's got subtractions, but it's also got a division in. Okay, so for these ones, it really does matter that you identify u and v correctly. You get given this. So you don't have to remember that u is on the top because it says it, but it should be pretty obvious to you because u is sat on the top here. The one on the top is gonna be your expression for u, and the one on the bottom is gonna be your expression for v.
So if u is on top, the top would be v?
Yeah, but it won't be. This is how it's given to you. Okay, so it's always given to you in this format, so you're gonna just follow these. So u will be the one on the top. So for this is quite a nice straightforward one. Okay, unfortunately you're less likely to get these, but so this top one is going to be u, and this bottom one is going to be v. So I'm going to say u equals 3x plus 2, v equals 2x plus 1. Nice and cinchy, yes? Well, as I did before, we're going to differentiate. Oh, I don't know how I said that. Differentiate. So we'll write du dx. So du dx in this case is 3. And dv dx is 2. Okay, now we need to follow that complicated formula. So, well, when I say it's complicated, it's just, you just need to stick things in the correct place. Okay? So, they start with v, and they multiply that by du dx. So, we're starting with v. We're multiplying that by du dx. Are you happy that I'm going to stick a 3 in front of that bracket?
Mm-hmm.
I'm then going to subtract. Okay, going back to the formula. So, I've got u multiplied by dv dx. So, u is 3x plus 2, and I'm multiplying that by dv dx, which is 2. So again, I've been sneaky and just stuck the 2 in front. That's then divided by v squared. So whatever v is, 2x plus 1, we're just going to put a squared sign around it.
And then you don't have to do anything.
Okay, now, if this was the question, it's quite unlikely, but if this was the question, I would expect you to be comfortable to expand this out and simplify it. Okay, it's not hard algebra. It's nothing. It's not really too taxing on the brain. So I would probably expect you to expand this one. So this bracket here would become 6x plus 3.
Yeah, 2x plus 1. Yeah.
But what? No, remember, because on the top we have 2 different terms, and you can't just cross it out of one of them. You have to cross it out of both of them. Okay, so don't go back into those kinds of habits. So I'm expanding my first bracket, it becomes 6x plus 3. Don't forget, this negative sign here belongs to everything on the right-hand side. So this would be minus 6x minus 4. Okay, so the negative 2 times 3x gives negative 6x, and the negative 2 times the positive 2 gives minus 4. Well, then you can see that your 6x take away 6x cancels out. You've got 3 take away 4. So you've just got negative 1 over 2x plus 1 squared. There's your question finished. All right, so this one here, sometimes questions are written like this. Okay, so they haven't labeled this expression here as y equals. But what they've said is find the derivative of it. And so because this doesn't have a label, they've just said d dx. So this just indicates that you're finding the derivative of it. So just be aware that if you see stuff like this, And it freaks some people out when they've got questions written in a slightly different way, but try not to freak. You're just differentiating the same way, yeah?
Are the bits on the top of the fractions would be u over dx minus u dv over dx? Are those interchangeable?
No.
Like, you can't switch.
No, because
you can't make always u over dv over. I mean, like, not like switch the fraction completely. I mean, like, do instead of v.
no, and that's
dx.
no, because no, because of the subtract sign, the order is important. So you have to start with v. You can switch these two, the v and the du dx, because those two things are being multiplied together.
So the one we just did.
So I apologize. And maybe that's what I did, because this and this, you can switch that. You can, the order of those two doesn't matter because they're being multiplied together. You cannot write all of this stuff over here,
Okay.
because it has to be this one subtract this one. So I did write my du dx in front of the v, and I did write my dv dx in front of the u.
No, I don't mean like that. You mean like put the on the top? No, that's not what you know.
Sure. All right, so here, which was my u, which was my v? My u is x cubed. My v is 4x plus 1 squared. So du dx, 3x squared. Straightforward. This one, not as simple. Why? What do we have to use here? Chain rule, okay? Because it is a function with a power. So remember, our power comes in front. Keep our bracket as it was, don't change it. Take 1 off the power. Well, obviously that's now power 1, so I don't need to write it. We're then going to multiply that by the derivative of what's inside, which in this case is 4. I'm going to simplify that to be 8. Now, you can expand that bracket if you wish, because we no longer have a power. Would you rather do that? Okay. So this would become 32x plus 8. So now we're going to substitute the terms in, or the expressions into the right place. So dy dx equals, had to start with v, 4x plus 1 squared, du dx, minus x cubed, bracket, 32x plus 8, close bracket, 4 over, now we've got 4x plus 1 squared, but we have to square it. Oh, I may as well write it like this. Here's our laws of indices. What happens when we have a power outside of power? We multiply them. So what we can now do is write, oh gosh, is write 3x squared bracket. I mean, oh, I don't know why, I just changed the order. You don't have to. Sorry, that freaked you out. So this would just be 4x plus 1 to the power